Hello everyone! Today we're going to talk about putting atoms together. So we mentioned this term alloy earlier on in the unit. An alloy is formed by combining two different metals. So for example, sterling silver, I don't know if any of you have this fancy silverware in your house, but it's actually not made up of pure silver. It's 92.5% silver and actually 7.5% copper. Two different metals coming together to form an alloy. Another way that elements come together is to form ionic compounds. So this is formed by combining a metal and a nonmetal. So remember that metals become positively charged ions and nonmetals are negatively charged ions. So you can see in the diagram here we've got sodium, which is a metal, and it's going to lose an electron to chlorine, which is a nonmetal. So sodium becomes the positively charged ion, chlorine becomes the negatively charged ion. Okay, opposites attract and they form this ionic compound. When we're naming ionic compounds, they can have common names, which is like a name that we would just hear in the grocery store, but we're going to focus more on their chemical names. So a chemical name, the metal name stays the same, but the non-metal element gets an "ide" ending. So for example, NaCl, that's commonly called table salt, but its chemical name is sodium chloride. So you can see that chlorine changes to chloride. Another way that atoms are put together is to form molecules. So these are formed by two nonmetals. And when nonmetals are coming together, they're not gaining and losing electrons, they're sharing electrons, as you can see in this diagram here. Molecular elements are a molecule that consists of atoms of the same element. So it's not two different nonmetals, it's atoms of the same element. So there are 7 molecular elements, and we're also going to call them diatomic molecules. You can remember which 7 are molecular elements by using the acronym Hofbrinkel, H-O-F, B-R, I, N, and C-L. So that means any of these elements, when they're by themselves, not combining with another element to make a different type of molecule, they exist in a pair. So for example, hydrogen, when it's not with another element, will be H2, and we just call it hydrogen. Oxygen, when it's not combined with another element like carbon or hydrogen, for example, okay, it will be O2. Fluorine will be F2, etc., etc. Okay, so for Br, Br2, I2, N will be N2. Okay? Okay, and when we're writing down how many elements there are and what elements are combining, that forms what's called a chemical formula. So it tells you the type of the elements involved and the number of atoms. So a common chemical formula that you would already know is CO2 or H2O. Okay, so for CO2, that chemical formula tells us that there is 1 carbon atom and 2 oxygen atoms in that particular molecule. So what we just did there was counted atoms that were in carbon dioxide. Okay, so the numbers that are smaller numbers are called subscripts. So the subscripts in a chemical formula tell us how many of each element are in the molecule. So for CO2, the subscript was that small 2 underneath oxygen. If there's no subscript underneath an element, you can assume that there's an imaginary number 1 there. So again, for CO2, it tells us that there's only 1 carbon because there's no other number written below carbon. If there's a bracket around part of the formula, the number on the outside of the bracket multiplies the subscripts inside the bracket. This is where it gets a little bit complicated, but don't worry, we'll do lots of practice with this in class. Bravo, you're finished. We'll see you in class.